All right, so today we're going to be solving equations with variables on both sides. So we have to first simplify each side of the equation. So we might need to distribute, we might need to combine like terms. If each side of the equation already is in simplest form, then we're ready to use inverse operations to solve the equation. The whole point of the equal sign is to keep the equation balanced. So whatever we get as our solution will make the equation equal. So in this example, we look to see if we have anything that we can simplify. Well, 4x minus 3, those are unlike terms. 2x plus 5, those are unlike terms. So we have 4 options about how to start this problem. Your goal is to collect variable terms on one side of the equal sign and constants on the other side of the equal sign. So I started this problem by subtracting 2x from both sides. Notice when I subtract the 2x, I put it under its like term here on the left. So 4x minus 2x is 2x. The negative 3 will just come down. Our additive inverses cancel out, and then our 5 comes down. And now it looks like a two-step equation. Cover up the variable term, use the inverse operation to get rid of the constant, then finally bring down that final variable term and divide. But there's 4 ways I could have started this problem. I could have subtracted 2x, which is what I did. I could have also subtracted 5 from both sides. That would have been fine. I could have also subtracted 4x from each side. Or I could have added 3 to each side. Any of those 4 options are good options for beginning this problem, as long as you collect variable terms on one side and constants on the other. Let's take a look here at A. So I'm going to draw my line down my equal sign. So we have 4 options of how we can start. First, I see that both sides are simplified, so I don't have to do anything with distributive property or combining like terms. So my options are, I could subtract 5y because that's the opposite. I could add 3 because that's the opposite of negative 3. I could also subtract 2y, or I could subtract 12. I'm going to subtract 5y just so we see different ways to move variables and variable terms. So 5y minus 5y is 0. The negative 3 comes down. 2y minus 5y is negative 3y. And the plus 12 comes down. And now it's like a two-step equation. Cover up the variable term, move the constant to the other side with inverse operations, add and keep the sign, and now it's a one-step equation. Divide by your coefficient, and we have our solution. Let's take a look at B. What are the 4 ways you could start this problem? I'm going to do something different this time. I'm going to start with adding the constant to see what happens. So the 6x comes down. 14 plus 7 is 21. My additive inverses cancel out. And I have my negative x. Well, I move the constants to the left of that equal sign, so I know I have to move the variable terms to the right. Additive inverses cancel out. Add and keep the sign. Divide. And we have our solution of negative 3 equals x. Take a look at C. Now here we see that one side has a variable term and the other side has a variable term and a constant. Would it make sense to subtract the 4 to start here? Not really, right? Because if I subtract this 4, all I'm doing is I'm moving the positive 4 to the other side of the equation. That's not going to be helpful. Because remember, our goal is to collect variable terms on one side and constants on the other. If there's only one constant, leave it where it is. Would it make sense in this case to subtract 4x from both sides? Probably not, because that would leave us with 0 on one side. Now that's okay. But if you have 0 on one side of your equal sign, then you're going to have to move either the variable term or the constant back to the other side. So we want to be as efficient as possible. 4 is the constant. I'm going to leave it over there. So my best and most efficient thing to do here is to add 7x to both sides, which will get me 11x equals 4. I'm going to divide by my coefficient, and we get x equals 4/11. Now this is a perfectly lovely solution, 4/11. It's a fraction, it's rational, great. Don't worry if you get a fraction as an answer. You just might want to check it. So let's check it. 4 times 4/11 equals -7 times 4/11 plus 4. Well, this is 4 over 1. So this is 16/11 equals -28/11 plus, we need this to be 11ths as well, 44. Well, 16/11 equals, what's 44 minus 28? Different sign, subtract, keep the sign of the higher number. It's 16/11. So that checks out, which means our solution of 4/11 is correct. On D here, what do you think we're going to have to do first? Did you say distribute? Absolutely. So we have 3x plus 12 equals what? 2x minus 3. Exactly. You finish solving this problem now. Now, students will look at a problem like E and get overwhelmed, but you know all the skills to do this problem. The first thing we're going to do is distribute and combine like terms where we can. So the 3x comes down, we'll distribute the 2. So we have plus 4x minus 10. And on the right side, we have some like terms that we can already get started with. 2x minus 5x is -3x. 6 and 4 is 10. Then we have a few more like terms on the left-hand side here, 3x and 4x. And now we're ready to go. We have simplified each side. What do you think a common mistake here is? A lot of students start by subtracting 10, which is fine. And they say that this side is 7x. Is that correct? That those cancel out? It's not. Common mistake. -10 minus 10 is -20. We'll collect the variable terms on the other side. Divide by our coefficient. And so we have one solution again, x equals 2. On F, go ahead, change this to an equal sign. Try F on your own. Try G on your own. Try H on your own. Now, all of the equations that we've just solved have had one solution. X equals 2, x equals a half, x equals 4/11, x equals 3. All of those are one solution. Now let's see a different type of solution. So let's take a look at I. If we put our line down, our equal sign here, we take a look. Well, our options are subtract 3, add 4x, add 7, or again, add 4x. Well, if I add 4x to both sides, my constant comes down, my inverses, additive inverses cancel out, equal sign stays on the line, my constant on this side comes down, and my additive inverses cancel out again. So my variable term is gone. So does 3 equal 7? Never. So this is telling us that there is no solution. There is no value of x that will make this equation true, and let's take a look why. If we have this equation, if you notice, both sides have a -4x, but they have different constants. Therefore, the sides will never be equal, because if this is the same on both sides, in order to be equal and balanced, the constants would also have to be equal and balanced. Take a look at J. So our first step is to distribute. So we have 30 minus 12v equals -12v minus 4. Now, if you notice at this point that you see the exact same variable term, you can stop here. But you might not recognize it. So what happens if we keep going? Let's say I add the 4 to both sides. So we have 34 minus 12v equals negative 12v. I would still have to collect variable terms on each side. These cancel out, and we end up with 34 equals 0. Does it? It doesn't. No solution. There's one more type of equation that you might end up with, and that's with those with infinitely many solutions. So let's take a look. We have 6x plus 4 here. And if we distribute 4 times 3 halves is 6x, and 4 times 1 is 4. Do you notice that both sides of our equal sign are exactly the same? That means any number that I substitute for x here is going to make this equation true. Anything. A fraction, a decimal, a whole number, an integer, it doesn't matter. Again, if you don't recognize that, then you can go ahead and keep solving. Subtract 4. So that will leave us with 6x equals 6x. Again, those are balanced, so any value of x would be true. Let's say I keep going. Let's say I subtract 6x. Well, I'm going to get 0 equals 0. Does 0 equal 0? It does, all the time. So if it's equal, this is telling us that there are infinitely many solutions. There's so many different possibilities that they are infinite to make this true. Now, let's say at this level you had 6x equals 6x, and you decided instead of subtracting 6x, you wanted to divide by 6. So then we get x equals x. Well, does x equal x? Sure it does. So anything that I say is x, the other side is also x. So we're still back here at infinitely many solutions. One more. So if we distribute 1/3 to 2b, we have 2/3 b. 1/3 times 9 is 3. 2/3 times b is 2/3 b. And 2/3 times 9 halves. The 2's cancel out. 3 goes into 3 once, into 9 3 times. And once again, we notice we have 2/3 b plus 3 equals 2/3 b plus 3, which means we have infinitely many solutions. So we may encounter equations that have one solution, x equals 2, x equals 4, y equals 7, that have no solutions where we don't have a balance, or infinitely many solutions where the sides of our equal sign are exactly balanced, so any value will do. Time to go practice. Good job.